Today, we're learning about desktop agents. Coding AI agents help developers write code. AI desktop agents do the rest. They organize documents, fill in forms, download files, authenticate, and perform actions across applications. I wanted to find a good desktop AI agent, and I wanted it to be open source and self-hosted because I need transparency and don't need my data going somewhere else. I found Bytebot, which is a popular open source AI agent that uses a real desktop. If a human can do something with a keyboard, mouse, and screen, it can do it too. Plus, it already had over 2,000 stars on GitHub, so I decided to test it. It spins up its own computer to complete tasks. It isn't a chatbot. It isn't just a simple browser agent. It's an end-to-end AI agent that has its own Linux desktop. I can give it instructions, upload my files, and it opens apps, it uses terminal, the browser, it runs VS Code, handles two-factor authentication, completes captcha puzzles, handles broken selectors, drags files between apps, draws diagrams, and I still have full control. I can see every click, I can take over, interject mid-task, and then hand it back. Because it's a full desktop, I can install any apps and extensions, and it will be able to operate them. When I tested it, I realized how useful it is, because this is the agent that doesn't need an API. This is the missing layer of real automation. The best use case I see for desktop agents like this is accomplishing the annoying 80% we all avoid, working with disorganized files, navigating messy interfaces, and actually completing work that spans across several applications. Watch till the end as I will explain how this actually works, where it's genuinely different, and share my honest take on it. Let's focus on the real problem that desktop AI agents are trying to solve. Most of our work is scattered across different places. One minute we're pulling PDF reports. The next, we're filling out long forms. Then we're jumping into a custom desktop app to share status. Traditional automation tools break when things change. When a button moves or when there is an unexpected pop-up, we often need to integrate APIs and write a lot of glue code. And some apps don't have APIs at all. Bytebot starts from a different assumption. Let's give an AI the same tools a remote worker has: keyboard, a mouse, and a screen, and let the model do the work. If it can click, type, and read like a person, then it can use any app without bespoke integrations. Bytebot agent runs inside a container on our own infrastructure. We can choose to self-host it and run it in Docker, Docker Compose, or on Kubernetes, so we don't have to trust a cloud vendor with our data. We can also one-click deploy the agent to Railway. We supply our own API keys for the language models we want to use: Anthropic, OpenAI, Google, and there is also a configuration that supports Light LLM as a proxy server, which means we have even more model options. Each desktop lives in its own isolated container, so if one agent gets stuck or misbehaves, it doesn't affect our host machine. We tell it what we need done in plain English. It spins up a minimal desktop with just the essentials: a browser, a password manager, an email client, a file manager, VS Code, and a terminal. We can install any other applications as needed because it's a full OS inside a container. It can log into portals that require two-factor authentication using a configured password manager. There is an autonomous mode where the agent runs the task from start to finish, and we can view the virtual desktop in real time. There is also a takeover mode where we can jump in and take control at any time. Now, let's see how Bytebot works under the hood. There are 4 major components: a containerized Ubuntu desktop, an AI agent service that connects to LLMs, a web app for creating and managing tasks, and a REST API for programmatic access. When we describe a task, Bytebot's planner breaks it down to a series of keyboard and mouse actions. The core belief here is that any interaction with the computer can be reduced to 3 primitives: keyboard input, mouse input, and vision, like screenshots. There is a process called Bytebot D to expose these primitives: functions to type text, press key combinations, move or click the mouse, and capture screenshots. The agent uses the screenshots to understand what's on the screen and decide what to click next. Because the agent interacts with the screen rather than the DOM, it's resilient to UI changes and can work across any app. The containerized desktop is intentionally opinionated. They decided to focus on a single platform, Linux, because it's deterministic, containerizable, extensible, and debuggable. Most desktop tools try to map a UI into a structured representation or require you to write your custom scripts for every integration. Bytebot's design philosophy is to get out of the model's way and let it act like a remote worker. I think the remote worker abstraction has advantages. It's universal because it works across every app, OS, and website, and it has fidelity. Anything that human can click, scroll, or type, the agent can do too. It's composable. You can chain actions and learn from them, and it's observable. Screenshots make the agent's decision traceable. It's also extensible. We can add audio or sensors later without changing the core. Let's dig into some of the real-world use cases where Bytebot can really be useful. One big area is enterprise automation. We can imagine it logging into internal portals with two-factor authentication, downloading transaction files, and processing them across systems. It can navigate government websites to fetch regulatory documents and update compliance trackers. It can reconcile vendor invoices by downloading them, entering them into ERP systems, and processing them. Another huge area is development and QA. We can have a coding agent write new features, then use Bytebot to test them visually, reproduce user-reported bugs, or perform regression testing. Your QA team doesn't need to learn a new UI testing framework because it sees the screen like a human. It can detect UI changes across deployments that a DOM-based tool might miss. So it closes the gap between code generation and real-world execution. It's really aimed at the unglamorous, messy work that still eats up hours across operations, finance, HR, and compliance, especially the tasks that involve jumping between apps, copy-pasting data, and dealing with portals that have no APIs. We need to really watch the space of general-purpose desktop agents. They tackle a very real pain point: automating across unstructured, multi-app workflows without building a custom integration for everything. I'm genuinely excited about tools that empower developers and pioneers in this area like Bytebot. In my own workflow, I see a clear place to use it alongside my coding agents. I use a coding agent to write a new feature, then hand it off to Bytebot to test it visually and file a bug if something looks wrong. This closes the gap between code generation and end-to-end testing. And it's open source and super easy to try, so try it and let me know what you think. And as the models get better at reasoning, the potential for end-to-end automation of intelligent QA and deployment pipelines is huge. And because Bytebot is under Apache 2.0 license, you can extend it and contribute improvements. Make sure to like this video and subscribe to my channel. Thanks for watching, and I will see you in the next video. Your reality has changed. You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.